Whether you're building a new home or adding on, framing up the situation, or putting a roof over your head. If you need to rock it, roll it, or just get on with it, Hometime has a video to help you do it right. Transform your small bathroom into a luxurious master bath, or increase your home's value by updating your old kitchen. Keep your drains draining, your switches switching, and your footing firm. Whether you do it yourself or buy it yourself, Hometime's how-to video guides will help you get the results you want. Will make your next project a success. See your local home improvement retailer for the Hometime video that's right for you.
Hi, welcome to Hometime. I'm JoAnne Liebeler.
And I'm Dean Johnson. 4 months from now, there'll be a house here, and we're going to build it.
Well, now hold on. We're not going to actually drive every nail and set every brick. But we're going to be involved in every step of the construction. We're going to serve as our own general contractors.
This is the first of a two-tape series in which we'll build an entire home. During the process, we'll show you some of the risks and some of the rewards you may encounter if you decide to build your own house.
We'll take you through the whole process, from an empty lot to a finished house, showing you all the steps along the way. It's not a job for everyone, but we think after watching these two tapes, you'll have a pretty good idea of what's involved, and you can make an informed decision about whether it's a job you want to tackle.
Hometime is made possible by Chevy full-size pickup, the most dependable, longest-lasting full-size pickup on the road. The national PBS series Hometime is made possible by the Stanley Works. Since 1843, Stanley has been committed to building quality tools and other products to help you do things right. At Hometime, we believe the best way to get the job done is to use the finest tools.
And this Chevy full-size pickup is one of our favorites. Equipped with an optional Vortec 5700 V8 engine, it generates 255 horsepower and 330 foot-pounds of torque to power you through the toughest jobs.
And with the optional third door, you've got lots of room for all your other tools.
And friends to help you use them.
At home or on the job site.
For work or play,
It's no wonder we at Hometime count on Chevy full-size pickups.
the most dependable, longest-lasting full-size pickups on the road.
Being a general contractor doesn't mean you have to know how to actually build the house yourself. So from that standpoint, this isn't really a do-it-yourself tape.
In fact, it's probably more of a manage-it-yourself tape. Being your own general contractor entails planning, budgeting, scheduling, ordering materials, hiring subcontractors, and just being the person responsible for managing the entire project.
You take the financial risk, so you also stand to reap the financial reward. And this isn't a job for anyone. In addition to watching the tapes, you should do as much research as possible.
We've listed several books and reference materials in the project guide that accompanies these tapes. And it pays to talk to lots of people and ask lots of questions. We're like friends who have done remodeling projects or who have bought a house from a builder.
Local building supply centers.
City inspectors and planners. These are all people who are probably willing to help you out.
And let's take a moment up front to spell out the pros and cons of being your own general contractor.
If you do it yourself, the disadvantages are that you need to set aside a lot of time. It's easily the equivalent of an extra full-time job for 4 months or more. It's not something you can do with a few phone calls each day and some paperwork on the weekends. Another disadvantage is that no matter how much research and planning you do, you're bound to make some mistakes that an experienced contractor wouldn't make. And there's no guarantee that your mistakes won't be serious and expensive. When you act as your own contractor, you assume the risk. If it's not done on time, if it costs more than was planned, it's your problem. A one-time homeowner doesn't have a lot of clout with the subcontractors who do the actual work. They may want to devote their manpower and equipment to bigger projects for bigger customers. This can upset your schedule and increase costs. Subs are less likely to do this to a professional contractor who might very well hire their competitors next time.
Where are those guys?
The major advantage of being your own general contractor is price. You pay a contractor for his work, his experience, and for taking the risks. If you're willing to assume those responsibilities, you can save yourself money. We're hoping to save about 20% by doing the contracting ourselves. When we get to the end of the project, we'll take a look and see how we've done. And maybe more important is the satisfaction you'll get from being involved in every step of the process.
Whichever path you choose, the more you know, the better off you are. If you use a professional builder, you'll get better service from the contractor, and he or she will find it easier to deal with you if you know what your job's about.
And if you think you want to be your own general contractor, what we show you on the tape should give you some idea of what's involved.
Well, many of the things we'll be talking about on the tapes will apply to your projects, even if they're smaller ones, like building an addition or refinishing a basement or a garage.
And perhaps the most important part of a contractor's job is the planning and design that takes place before the first shovelful of dirt is removed for the foundation.
Speaking of that, let's see what we've got here.
Okay?
The first two things we need to think about are finding the site and the designing of the house. In the best of all possible worlds, you'd go out and find a piece of property that you like, buy it, and then have an architect design a house specifically for that site.
However, in the real world, this procedure can be somewhat of a luxury. Not many of us can afford to sit on a lot while we have a house custom designed. More often, we're in the position of finding the property and lining up a design at the same time. One good way to get a design together quickly is to make use of a plan service. These firms usually advertise in homeowner magazines. They'll sell a complete set of blueprints for a tested and proven house design for around $100 to $150. There we go. That's the one.
We picked out the one we liked, bought the plans, and had an architect make some changes in the design. Most of the house is on one floor, including a small formal living room, a family room, and a master bedroom suite. Upstairs is a loft area with 2 more bedrooms with their own bath. The house has some interesting roof lines, which will make for a 2-story vaulted ceiling over the family room. The changes we made had to do with our Minnesota climate. For instance, exterior walls here have to be made of 2x6s instead of 2x4s. This gives room for the extra insulation needed for the cold winters here. Other changes were less structural and more practical. The original design called for a curved glass block wall around the bath and shower area of the master bathroom. With our cold winters, we changed that wall to mostly tile with just 3 courses of glass block along the top of the wall. In the original design, there was a shop area here, open to the garage. We had that changed to a laundry room, or what's usually called a mud room here. It's a place to leave your muddy shoes and boots during bad weather. We also specified a tile floor in the foyer for the same reason. Well, I think we have ourselves a solid plan here.
Yeah, I can't think of any changes I'd want to make at this point.
We've illustrated one very good process for house design. Take an existing plan to an architect and have it adapted to suit your personal taste and local building requirements.
And it doesn't always have to be an architect. There are drafting services that will draw up complete sets of plans for less than an architect would. Typically, an architect will run about $50 an hour and up. To make changes to our plan cost about $400, whereas a drafting service will be about $25 an hour. At the same time, you get what you pay for. A drafting service won't give you much design help.
For a simple 2-story house, a local architect or draftsman should be able to make sure that your design is structurally sound and complies with local building codes. The lumberyard that calculates your wood order and the local building inspector are other people you should alert to watch out for design flaws.
Once you have a final plan, make about 20 copies. You'll need these for the different subcontractors and suppliers.
Again, we can't stress how important thorough planning is. It'll save you time and money and aggravation down the road. Designing the house is only half of the planning job. You also need to figure out if the house that you want will work with the land that you want. And this goes way beyond just looking at the lot and trying to visualize what the house would look like on it.
One thing to consider is there might be architectural covenants on the property. These are usually created by the developer or a residential association to make certain that the neighborhood maintains a consistent look.
For instance, we bought the land from the country club that's behind the property. They specified that we could never build a pool or a tennis court on the land because they felt as though it would detract from the golf course. Well, this restriction will be part of the property forever, and it will be binding on anyone else who buys the property in the future.
Another thing to consider when looking for a lot is soil and drainage. You don't want the basement to flood every time it rains, and you don't want the house to settle after it's been built. Now, a homeowner can handle a lot of this with a little common sense. First of all, take a look at the land.
If it's located at the bottom of a gulch or the lowest part of a field, think again. A good site will have a little slope or grade to it and an obvious path for stormwater flow. Here, where we'll be locating the house, is a low part of the property. However, we can change that by using dirt from the excavation to raise the level of the ground around the house. But the rainwater still needs a place to go. Our property has a slight grade near the front of it, so some of the rainwater can drain into the street.
There's also a slope toward the back, so the rain will drain toward the back of the property. Eventually, it'll drain into a storm drain in the back of the lot 2 houses over. Now, normally we don't have the right to drain our rainwater across this lot into the storm drain. Every owner has to deal with the rainwater that falls on their own property.
There are exceptions to these rules called easements. An easement is a legal right written into a deed of a piece of property. Well, for instance, the country club has an easement allowing them to drain water onto our property. And when this area was developed, the developers included an easement on the next piece of property, allowing us to drain across it.
One last thing to check on before you purchase a lot is utilities. In this development, all the water, electrical, gas, telephone, and sewer have been run up to the edge of the property. Our only expenses will be the hookup costs and fees. However, we did do a little research on the sewer connection. The line running from the house to the sewer has to slope downhill, so the force of gravity will move the waste from the house into the sewer.
The lowest point of the drain system in the house will be 2 feet below the floor of the basement, and the floor of the basement will be about 8 feet below the current ground level. So from that point, 10 feet below grade, the pipe needs to slope down at least 1 inch for every 4 feet that it travels horizontally. That means our connection point needs to be at least 12 feet deep.
In our case, the connection point is 17 feet below the street. This dimension is called the sewer invert. Now, if the sewer invert isn't deep enough, we'd have to install a lift station in the house. Not an insurmountable problem, but at the same time, it's something you should research before you purchase the property. Now let's take a look to see how we can place the house on the lot. Our site is very wide and not particularly deep. The first thing we need to think about are setbacks. These are the zoning laws that dictate how close to the property lines you can build. In our town, there's a 30-foot setback on the front and back, a 7-foot setback along the garage side, and a 10-foot setback on the other side. This severely limits where on the property we can locate the house. We're going to place it as far to the south, that is, the left side of the lot, as possible. With a little imagination and a fancy computer, we can begin to picture how it's all going to look.
When you come in the front door, you'll be in an entryway with a view to several rooms of the house. To the left is a small formal living room. To the right is the dining room. There's a powder room off a small hall near the front door, too. Straight ahead is a large family room. This is the real heart of the house. The kitchen is at the back of the house, separated from the family room by a counter. The kitchen is large enough to include a breakfast nook. The laundry room leads from the kitchen to the garage. The master bedroom suite is on the first floor. This arrangement is becoming more and more common in new construction.
The second story is small, covering only the dining room, kitchen, and laundry rooms. There are 2 bedrooms on the second floor. They're connected by a bathroom, and there's a loft area that overlooks the family room. The rest of the rooms on the first floor have high vaulted ceilings, which increase the overall feeling of space in this modest-sized house. The vaulted ceilings make for an interesting roof line. We'll be surfacing the roof with cedar shakes and finishing off the exterior of the house in a combination of cedar and brick.
Now, granted, most homeowners won't have fancy computer graphics to help them visualize a house. So let's take a moment to learn how to read building plans. A good set of plans will have 4 types of diagrams. The basic diagram is called a plan view, or just a plan. It's a view from straight above. There should be a plan for every floor. The basement and foundations, the main floor, and the second floor. An elevation is a side view. Here are the exterior elevations, 1 each from the front, the back, and each side. There are also some interior elevations. For instance, this elevation of the kitchen shows us exactly where the cabinets will go. There are elevations for inside walls, too. Plans and elevations, so far so good. But now it gets tricky. A section is a slice through the building sideways. For instance, if we took an enormous saw and cut the house open on this line the cross-sectional view would look like this. Notice that this section is called CC, and the line on the plan is also called CC. There are sections through many areas of the plan, and they're all labeled according to where they cut through the house. So plans are views from above, elevations are views from the sides, and a section is a slice of the inside. Now all of these diagrams are drawn to scale. However, they might not all be drawn to the same scale. The scale for each drawing will be labeled. For instance, the plan for the main floor says that 1/4 inch equals 1 foot 0 inches. This is called 1/4 inch scale.
An experienced builder will use a tape measure to read dimensions off of a plan. For the novice, there's this tool called an architect's scale.
If your plan is 1/4 inch, find that edge on the ruler. The 1/4 inch scale reads from right to left, and the numbers represent feet. So if I set the 0 mark on one side of the garage, I see that the garage is a little wider than 22 feet. To find out precisely how much more, I slide the 22-foot mark to line up with the outside wall. Then I go back and look at the beginning of the scale. You can see that past the 0 mark, there's 1 more foot's worth of markings that have been divided up into inches. The first side of the garage now lines up with the 3-inch mark here. So the garage is 22 feet and 3 inches. It doesn't take very long to get pretty quick and accurate with the scale rule, and many of the most important dimensions should already be marked on the plan. There are just a few more things you need to know to read plans. For instance, this mark on the section tells us that diagram 5 on page 9 is a detail drawing of this section of the cornice. Notice that this detail is labeled NTS, not to scale. It's just a drawing to show the arrangement of the pieces. Depending on how much you want to spend on your plans, you may choose to have some of these detailed drawings left off. Many of these small decisions can be left to your subcontractors.
We have detailed plans for the building, but we also need detailed plans for the property to show exactly where the house should be located. What we want is a survey.
Well, the surveyors will look at the plans and the property, research any setbacks, and will work with you to figure out the precise placement of the house. Once this is determined, a surveying crew will stake important locations, including the property lines and the corners of the house. Working off reference points, such as the fire hydrant across the street, they'll also note the elevation of the land. The excavator will need this information.
Once you're done with a survey, you'll get a piece of paper like this, a certificate of survey. It shows the exact position of the proposed building on the land as certified by the licensed surveyor.
Well, what do you think, Dean? Should we make it official?
Yeah, I think we're all set.
By that we mean getting a building permit. This gives us permission from the city to build. Now, the paperwork required for a permit varies from town to town. For us, it meant submitting 2 copies of our building plans, a copy of our survey, a certificate of insurance, pay a fee, and display in a prominent location.
When you pick up your permit, check to see what inspections are required in your area. Typically, there will be inspections for footings, framing, heating, plumbing, and electrical rough-ins, insulation, drywall, and a final inspection.
Now that the design process is over, our next step is to start hiring the subcontractors. These are the firms that actually do the work. They have the manpower, the tools, and the know-how.
Each sub does a different type of work. The general contractor doesn't have to know how to do each job himself, but some basic knowledge helps a lot.
So for each part of the construction, we'll explain the fundamentals of each job and do a few hands-on demonstrations.
For each part of the job, get bids from 3 different subcontractors. Check around. The local home center, building material supplier, other subcontractors, friends and neighbors that have had similar work done. Tap every resource you can think of to get leads on good subcontractors, including local newspaper ads and the phone book. Let's take a look at our drywall bids as an example. We got 1 recommendation from a contractor friend, and we got 2 leads from the phone book.
Then each sub got a set of our plans. Now, not every sub needs every page of the plans, so check with each one and see what they need. After a week or so, we got written bids back from each one of them, and you can tell a lot about a sub by just looking at the bid. For instance, look for it to be neat, organized, and thorough. This bid looks like it was done quickly and without a lot of attention to detail. These two look complete, and notice that both have specified that the bid doesn't include making some interior columns that are on the plan. So these subs obviously took the time to look at the plans carefully before making their bids. And finally, look at the prices. It's almost always true that the low bid is not the best bid, and you should immediately discount any bid that's unusually low.
Also remember that some subcontractors may not offer the best deal, nor their full time and effort to a one-time general contractor. A professional contractor, on the other hand, can offer a subcontractor repeat business. Then start by looking at references. References are the best advertising for any subcontractor, and the subcontractor should not be shy about offering them. If he is, beware.
Finalizing arrangements may vary from one contractor to another. A detailed bid can serve as a contract. You just have to sign and make your first payment. Other subcontractors may have standard contracts, and changes are inevitable. So expect them and be prepared for them. And make sure that any changes, including costs, are agreed to in writing in the form of a change order.
And finally, make sure that each subcontractor carries workers' comp and liability insurance. Ask for a copy of their certificate of insurance. This means that he's covered in case there's any accidents on the job.
One of the contractor's main jobs is scheduling, and it can get a bit complicated. It's not an exact science. So you'll need a lot of paper, some pencils and erasers, or a computer, or something like this. We'll be working over about a 4-month period, and in that time there will be a lot of changes. So in order to see what kinds of different things will be going on at any one time, we set this up. And the whole construction process begins here with the excavation. Then come the footings and foundation. Then the waterproofing and insulation on the foundation. The framing takes place from here through here. And when that's done, several things can start happening at the same time. The heating system can be installed, and the windows and doors can go in. When the heating is done, the plumber can start his rough in. And when the carpenters finish the windows and doors, they can start on the roof, and then the siding, and then the exterior trim. Or if you've got a separate roofing crew, they can start on the roof as soon as the plumber has run his vent pipes, assuming the mason has had a chance to run the chimney up past the roof line. As you can see, it can get a bit complicated. But rather than explain all the intricacies of scheduling up front, we'll refer to this schedule throughout the building process, and we'll explain how the different parts of construction overlap and interrelate. And I'm sure before it's all said and done, we'll have made very good use of this. Come to think of it, Monday's a holiday. Framing is supposed to take 3 weeks, but that's going to move it down.
While you're collecting bids and choosing subcontractors, you'll need to figure out a way to track your expenses. There are a few standard forms available for doing this. We've included a sample form like this in the project guide. You should write down each subcontractor's bid and leave a column for the actual cost. You can see that so far, we've spent $125 for the basic design, $500 for the changes to it, $76.20 for 15 copies of the plan, $275 for the survey, $2,467.15 for the building permit, and $600 to have the trees removed from the building area. We believe you should pay your subcontractors and suppliers promptly. Normally you have a grace period in which to make this payment, but don't abuse it. Don't try to use your subs and suppliers to finance your construction project.
Financing can be a problem for a do-it-yourself contractor. Banks are going to be reluctant to loan money to someone who's contracting their own home. Now, it helps if you own the land free and clear, and you'll have better luck if you've done your homework on design, cost, and scheduling before you apply for the loan. The type of loan that you want is a construction loan. The bank lends you a certain percentage of your construction cost as you prove that a certain percentage of the construction has been completed. Now, while the building is actually going on, you pay only interest on the amount borrowed so far. And once the building is completed and you have a certificate of occupancy, then you can get a mortgage, and then you can pay off the construction loan.
One last tip on preparing for construction. Order your lumber and ceramic tile early. The lumber is a fairly complicated order, and it'll take a while for the lumberyard to put it all together. And it's needed very early on in the construction process, especially for the basement windows.
And ceramic tile is often custom fired on an order-by-order basis, or it's shipped from overseas, often from Italy. Most other materials are readily available, and it's usually the responsibility of the subcontractor to make sure it gets out to the job site in time.
Say, where are we on that ceramic tile order anyway?
Oh, I think I better make a call.
Yeah.
Right now, we've still just got an empty lot. But there are a few more things we need to get here before construction can begin. For instance, electricity. Often you can pull construction power from a neighbor. It's only for a few power saws and drills, and you can offer to pay the neighbor a little something each month before your house power is connected.
The alternative is to have an electrician hook up a temporary power drop. Now, the cost of this will depend on the utility company, but typically should run about $150 plus power company fees.
You should also think about getting a temporary phone installed. Your subs will need a way to get in touch with you while they're on the job. You can get a phone that you or one of the subs can unplug and take home each night, and you can get it restricted to local calls only.
Most of the organization, paperwork, ordering, and financing are behind us at this point. And really, what we've done so far is a large part of what a general contractor does.
However, the more you know about each phase of the construction process, the better off you'll be in the planning and preparation parts. So for the rest of the project, we'll be giving you an education on what each subcontractor does, how to get the best job out of each subcontractor, and how to manage the ongoing construction process. From the first-hand view of what we're going through, you'll be able to benefit from our experience in building a house.
So are we ready to start digging?
Well, you look the part, but I think you're going to need a bigger shovel. The excavator we're using has two big shovels. He's using a bulldozer first to scrape off the black dirt. He'll use a backhoe for the major part of the digging, getting the dirt out of the hole. And early on in the process, the excavator puts in offset stakes. These stakes are a certain distance back from each corner of the house, parallel to the sides of the house. This way, he can remove the stakes that mark the house corners and dig a hole that's a little bigger than the house itself. These offset stakes are crucial. They'll stay in after the excavation and will be used to locate the position of the foundation. The excavation for our house took one long day, and the job was made a little tougher by the soil, which is clay, and the water table, which turned out to be a little higher than we expected. But it makes for a heck of a bird bath.
After any excavation, you want to put in a layer of sand along the bottom. This will help keep things dry during construction. But because of our water problem, gravel will be necessary, and this will help drain away any excess water. This crushed limestone will absorb some of the water in the bottom of the hole and raise the working level of the excavation above the water table. The foundation sub is spreading it around with a bobcat. That's a brand name, but it's a term usually used to describe a small bulldozer like this one that's been driven right into the hole.
With the stone in, the crew can finally walk around down in the hole. So now we can get started on the footings. These are the poured concrete pads that the walls of the house will rest on.
The foundation sub constructs forms for the concrete. This will hold the concrete in position until it hardens. Now, part of the sub's job is to make certain that the footings are at the correct height all the way around the foundation. The footings transfer the weight of the structure to the ground, so the soil underneath the footing has to be stable. It must be undisturbed soil, or what's called approved compacted fill. Make sure the excavator and the foundation sub are aware of any soil problems and that any necessary corrective actions are taken. The footing for a building also has to be below the frost line so that the ground under the footing doesn't freeze in winter and try to push the footing up. In our part of Minnesota, the frost line is 42 inches below ground level. Since our building has a basement, we had to dig far deeper than that anyway. Once the forms are in place, there has to be a footing inspection. A good foundation subcontractor will schedule this pretty carefully so that the concrete can be poured right away. The building inspector will check that the footings are deep enough, wide enough, and will rest on a solid base. Then he'll sign the inspection record and the concrete can be poured.
This part of the job goes pretty quickly. The concrete arrives in a ready-mix truck, which backs up as close as possible to the site. The truck will pour the concrete into wheelbarrows. These are then wheeled over to the forms and poured in. As the forms fill up, they scrape them off to level with a shovel. The finished product may not be beautiful, but it's not a sidewalk either. The foundation sub buys the concrete from a ready-mix company, so ready-mix suppliers are a good place to get recommendations for subs. And since our footings are being poured in sections, they're laying reinforcing rod, rebar, at the ends. That way, the concrete that's poured later will be solidly tied into the concrete going in now. The footings aren't the only place where we'll be using concrete. The basement floor, the garage floor, even the driveway will all be made of concrete. And we'll use the same foundation contractor for each of these jobs. All told, we'll use about 50 cubic yards of concrete, and that's about 7 truckloads.
The next step in our foundation construction is to load the concrete block into the pit.
Our house will have a foundation of 12-inch concrete block. It's also possible to have a poured concrete foundation. Poured walls are thought to be stronger, while block walls are thought to be less expensive. But it really varies according to the design. You should probably go with whichever is the more common in your area. The foundation crew starts by building leads. This means laying the block for the corners of the basement. The block used at the corners has a special inset on it. The block coming in on the other side fits into the notch formed by the flange and forms a snug corner. A cement mortar is used for the joints between the block.
When the leads are built, stretcher or regular block can be filled in between them. Notice that the crew is tooling the mortar in the joints. This packs the mortar in firmly, making the joint stronger and more waterproof. The sub is also sanding the footing. The sand protects the footing from any mortar that drops off the blockwork during construction. We'll shovel off the sand and harden mortar and have a nice square corner at the bottom of the wall. We're also sanding the footing on the outside. Our foundation insulation contractor asked for this, and you'll see later that this will give the sheets of insulation a flat surface to rest on. A 10 or 12-inch wide block is required in our area. 8-inch block may be allowed in other parts of the country depending on the climate. And we're using what's called modular block. This means that each block is 7 5/8 inches tall. Setting that on top of a 3/8 inch mortar joint makes each course 8 inches high. The other type of block, full height block, is a full 8 inches high. So each course ends up being 8 3/8 inches high.
Although the foundation will have 12 courses or rows of block, they'll only lay the first 7 courses now. Once the whole foundation is 7 courses high, they'll set up scaffolding and set the last 5 courses.
The measure of a good foundation is how level and plumb it is. A foundation that's more than 1/4 inch out of plumb, or which varies in height of more than 1/4 inch over 20 feet, could cause problems for the carpenters when the framing begins.
Our foundation subcontractor is putting re-rod through the block vertically. The cores of the block get filled with grout, making in effect a solid masonry wall. This technique can be used to strengthen any sections of a basement wall that must resist heavy lateral loads.
A few other interesting things about our foundation. Because the master bath here is lower than the rest of the first floor, there's a ledge here that'll support the floor joists coming across. And these are fill-top block, which you'll commonly find around the top course of the foundation. And the anchor bolts secure the framing to the top of the foundation. Now we're done with the basement block. They're still working on the garage. But Joe and I can move on to the next step, which is waterproofing and insulating the foundation.
This is a job you can sub out, but it's also a good project for a couple of people who have a spare day and want to save perhaps $1,000 on construction costs.
It's become common practice to put insulation on a foundation.
An uninsulated basement foundation can account for 22% of the heating loss in a house.
Here in our cold climate, we want insulation all the way down to the footings. And the only time to do it is after the foundation is complete, but before it's been backfilled.
It'll require a few basic tools, many of which you already have, and materials that should be available at your local home center. There you go. I got this end, Joe. First, you apply a layer of waterproofing. We use a black waterproofing mastic that can be applied with a regular paint roller. We use a roller cover with a very thick nap. This can get messy, so we're wearing disposable paper coveralls.
We coat everything from the footing to one course down from the top of the block, and we work on an entire wall at a time. Next, we apply a polyethylene moisture barrier. This is 6 mil poly, 8 feet wide. The poly comes folded up, and we roll it out at the top of the wall. Then it gets trimmed to length. Finally, we let it fall down to cover the wall. Some people call this step waterproofing. That's kind of misleading. It's probably more accurate to call this damp proofing. The insulation we're using is 1-inch styrofoam. Styrofoam is a brand name for extruded polystyrene. Make sure you use extruded polystyrene, not expanded polystyrene, which won't hold up underground. These are 4x8 sheets. Since the foundation is exactly 8 feet high, the sheets fit perfectly onto the wall.
To fasten the foam, I drill through the board and into the block with a 1/4-inch masonry bit attached to a heavy-duty drill. Then a special fastener gets hammered in. The end of the fastener spreads apart in the block, anchoring the foam. We use as few of these as possible, since each anchor puts a small hole in the damp proofing. Just 2 anchors near the top of each board, and 2 more at a foot below ground level. Well, they've just begun to backfill the foundation, or push the dirt back in around it. And believe it or not, it's going to take all the dirt we dug out of the hole to do this.
All that dirt creates a lot of pressure on the foundation walls. To keep the walls from being pushed in and falling down, bracing had to be installed. The bracing runs from the middle of each wall down to the footings. The corners tend to be pretty strong, so bracing is crucial in the middle of the long walls. Now, the clay soil here is very heavy and very hard, so the bracing is important. And this is a job that can often fall in the cracks between subcontractors. Well, the carpentry sub is the best bet for this project. So before you finalize your bid, make sure that he knows this is expected of him.
Backfilling is also part of the excavator's job, so don't forget about him once the hole's dug. Another part of the excavator's job is to fill the garage with sand in preparation for the concrete floor.
Here you go.
I got it.
With the foundation backfilled, we're ready to start the framing. So far, we've seen this project progress from an empty lot to a hole in the ground to a finished foundation. This is exciting work in its own right, but framing will be an even bigger thrill.
In what will seem like a very short time, the whole structure of this house will be visible.
The carpentry subcontractor who does this work can be of a lot of help if you're serving as your own general contractor.
Many general contractors started out as carpenters, and many carpenters do general contracting. So hire the best carpentry sub you can find, and look for one that you think might lend you the benefit of his experience.
As we watch our framing crew go at it on our house, we're going to build our own framing project here in the Project Center. This will help us get familiar with the tools, terms, and techniques of framing.
This way, we can talk intelligently with the carpenters about framing. This knowledge will also help out in the planning process, making it easier to read blueprints and make design choices.
We're going to build a simple one-story structure with a roof, kind of an oversized doghouse. But this will show us the principles of platform framing.
Almost all new residential construction uses platform framing. There's another technique called balloon framing. This is a slightly different and older technique.
The first thing that goes on top of the foundation is this sill sealer. This is a thin strip of either fiberglass or foam. We're using foam. It lays across the top of the block, and I push it down around the anchor bolts.
The sill sealer fills any air gap between the block and the first piece of framing lumber, the sill plate. This is a 2x6 that lays flat on the block. We drilled holes in it for the anchor bolts, and nuts and washers screw down over the bolts to hold the sill in place. The sill plate is made of pressure-treated lumber. This is wood that has special preservatives in it to prevent decay. The sill plate gives us a base for the wooden part of the structure. Now we're ready for the joist.
A joist is a piece of lumber that supports the floor. Joists are dimensional lumber, 2x8s, 2x10s, or 2x12s, and they're laid on edge. The first joists that go in are the rim joists. We start with two 2x8s. These are nailed together at the ends to form the first corner. Then we work around the foundation, nailing each rim joist into the end of the last one. Okay. Finally, we attach it to the sill plate by toe nailing. This means driving nails in at an angle through the bottom of the rim joist and into the top of the sill plate.
The floor joist will now go in between the rim joists. To help us position our floor joist properly, we'll take our spacings off of two opposite rim joists. The joists are spaced 16 inches on center. This means that the centers are 16 inches apart, but that there's actually 14.5 inches between the joists. When you see the note OC on a plan, it stands for on center.
The floor joists rest on the sill plate at either end. We secure them in place by nailing through the rim joist and into the ends.
For these nailing jobs, we're using a framing hammer. It's typically about 22 ounces, and it is heavier than a regular hammer.
When the floor joists are in, we can go back and install bridging between them. Bridging and blocking are ways to provide lateral support for joists. Check with your building inspector to make sure that these go in properly and aren't removed by plumbers or heaters. So, those are the basic elements that go into getting a floor down.
Sill plates, rim joists, floor joists. Seems pretty simple, right? In reality, most homes will have more complicated elements in the simple structure that we're making in the studio. For instance, this house is 30 feet from the front to the back, too long for a single joist. Even a 2x12 would sag in the center. The solution? To run a beam down the center of the house. This way we have two sets of joists, none of them having a longer span than 17 feet.
The beam is made up of two 2x12s, which are nailed together. It'll be supported by steel posts, each of which will rest on square footings.
Beams can also be made out of structural steel. 2 floors of load-bearing walls rest on this beam, so our architect decided to take no chances and opted for steel. Notice down on this end that the beam rests in a pocket in the block wall.
Our contractor installed the rim joist and the sill plate so that they'd hang out just slightly over the foundation block. That way, when the half-inch sheathing is installed over it, it'll be flush with the foundation insulation. Then the siding will run down and cover the top of the insulation and protect it from any water damage.
The details of the lumber order, how many pieces, what size, and what grade, are determined by the lumber yard. They have people on staff that take a look at the plan and do a material takeoff. That's how they figure out what to bid the order at. Then the lumber gets delivered in a couple of loads. So far, we've only got what's called the cap load. This is what's needed to get the floor of the first story completed. The carpenter will arrange with the lumber yard to have the materials delivered as they're needed. The more detail there is on your plan about lumber size and grade, the less chance there is that the lumber yard will choose materials that don't meet code.
And of course, sometimes there are problems. It's the job of the general contractor to make sure that any gaps in the order get taken care of.
Got it?
Yep, over to my side.
Yep.
probably noticed our framing crew using an air-powered nailer like this one. If you've got a big job, it can really speed things up. Here we use one to secure the subfloor to the joists. The subfloor is most often half-inch plywood. More layers of underlayment go on top of this later on in the construction process.
Now for some walls. The basic elements of walls are plates and studs, and we'll be using 2x4s for these. Standard practice is to lay out a wall flat on the floor and then raise it up. First we position the top and bottom wall plates. The ends of the studs will butt into these, and we've already marked where these will go. We nail into the studs through the plates, 2 16-penny nails at each end.
Like joists, studs are spaced 16 inches on center. When a wall is complete, then we raise it up. The outside of the wall is placed flush with the outside edge of the floor. Then we nail the bottom plate into the floor. The bottom plate is also called the sole plate. Once the plate is secure, we check to make sure the wall is perfectly vertical. Carpenters call this checking for plumb. Then we brace the wall in place.
Where 2 stud walls meet in a corner, a little extra construction is needed. We put 2 studs at the end of the wall and space them apart with small pieces of 2x4. This creates a stronger corner. It also makes a nailer for the drywall on the inside.
Once the walls are up, we nail another plate, a top plate on top of the wall plate. This gives us another way to reinforce the corners. There are some special terms and techniques that come up when you're working on a wall with windows or doors. Because the openings mean fewer studs in that section of the wall, they require some special support. The piece at the top of the opening is called a header. Here it's made up of 2 2x6s with a piece of half-inch plywood sandwiched between them. The plywood makes the total thickness of the header 3.5 inches, the same thickness as the rest of the wall. Each end of the header butts into king studs, and it also rests on the shorter jack studs. The sill goes across between the studs where the bottom of the window will be. Then the sill is supported with shorter studs called cripple studs. The header supports the weight of the house directly above the window, which is why it needs to be a thicker piece of wood. And the heavier the load, the thicker the header needs to be. Because of the weight of the house above this doorway, the header here is made up of 3 2x12s.
Here where there's a second story above this wall, and the window opening is 8 feet wide, we'll be using a special product. This is a micro-lam beam. It's made up of laminated plywood glued together under pressure, and it's much stronger than dimensional lumber of similar size.
And what about a 16-foot garage door opening? Here we'll have a header made up of 2 micro-lam beams, each of which will be the size of a 2x12.
Window sizes vary greatly from manufacturer to manufacturer, so before construction can begin, make sure the carpenters know how large an opening to leave. Each window and door has a specified rough opening. The rough opening is a measurement from the top of the sill to the bottom of the header and the distance between the 2 jack studs. For the door, the vertical measurement is taken from the top of the subfloor to the bottom of the header. Now don't be confused with this section of the sole plate. That'll be removed before the door is installed.
Our studio demo used 2x4 framing, and structurally, that's all we really need. But here in our part of the country, we use 2x6s on all the exterior walls. This allows us to put in 6 inches of insulation, which is what we need here for our cold winters. And speaking of insulation, we've already had to put some insulation in. An interior wall will butt into this wall here. Once that wall is in place, there will be no way to get insulation into the cavity between these 2 studs. So the carpenters fill it in with fiberglass insulation before they put up the second wall. The rest of the insulation will wait until much later in the process and will be done by a separate insulation subcontractor.
Now, the only walls we've talked about so far are exterior. Interior are a little different. First of all, they're called partitions. Second, they can either be load-bearing or non-load-bearing. This depends a lot on the design of the second story and the roof. This is an example of a non-load-bearing wall. It doesn't support anything above it. If this were removed, nothing would come falling down. Usually a partition that runs parallel to the floor joist is non-load-bearing.
This wall is a load-bearing partition. It runs perpendicular to the floor joists, and the floor joists for the second story rest on it. Plus, there'll be another wall directly above it, which in turn supports the roof.
Attaching the sheathing has also been part of the framing process so far. Often the carpenters do this before they lift the walls into position. The sheathing gives the walls diagonal strength before they're tied into the rest of the structure. Other materials that can be used for sheathing include exterior grade plywood, fiberboard, and rigid insulation. The choice of sheathing depends on the exterior finishing materials. Some sheathing, like rigid insulation, requires a little additional wood over it so we have something to nail the siding into.
A truss is a combined unit that takes the place of standard rafter construction. In rafter construction, there are joists across the tops of the walls. These create an attic floor. Above each joist is a pair of rafters that slant up from the walls and meet at the peak of the roof. The angled ends of the rafters rest against a ridge board, which runs from one end of the roof to the other and holds the pairs of rafters plumb. A truss is one unit that replaces the triangular structure formed by a joist and two rafters. Trusses are usually made out of 2x4s, and they come in a couple of configurations. Depending on the roof and the type of ceiling, you can use a simple king post truss. Now this truss is used for longer spans. It's called a W-type truss because of the shape of the bracing in the middle. And this scissors truss can be used when you want a vaulted ceiling in the room below. The slope of the roof is called the pitch in the construction business. Pitch is measured by how many inches the roof rises over a 12-inch horizontal run. So for each of our trusses, we have a pitch of 512. In addition, our scissors truss has a pitch of 312 on the inside.
The gable truss at the end of the roof is framed so it eventually can be sheathed and sided like the wall beneath it. We align the truss with marks on the top plate and toenail it into place.
Okay, Dean, you got it on the mark?
The rest of the trusses go up on the roof and get nailed into the top plate.
Okay, give me a little more.
Notice that the top plate of the wall fits right up to where the angled section begins. This last section of flat wood along the bottom of the truss is called the heel.
We've checked the trusses for plumb and braced them in place. The sheathing, which is the covering that goes over the trusses, will also give them a lot of support.
The sheets of half-inch exterior grade plywood go across the trusses and get nailed into place with 8-penny nails. We've marked on the plywood where the trusses should fall, so again, it's easy to make sure the trusses are properly aligned. On our little demo structure, one 4x8 sheet of plywood reaches from gable to gable.
Then we pull the temporary brace off and fit these last pieces on.
Like the other elements of this framing demonstration, we kept the roof and trusses as simple as possible.
Let's take a look at an intricate roof and see how that can change things. With a complicated roof like ours, the trusses will be complicated too. It's a time when you have to have almost a blind faith in your carpenters and the truss manufacturer. The lumberyard took our plan and designed and built the trusses, and each truss is designed for a specific area of the roof. But it takes a real experienced eye to be able to look at a given truss and say, oh yeah, that's where that one goes. Before the trusses can go on, the crew makes sure that all the exterior walls are not only plumb, but absolutely straight. This means putting braces in the middle of longer walls and correcting any bows in them.
One of the harder parts of putting up a roof is getting the trusses up there. Our carpenter keeps a forklift around to make the moving easier.
Using trusses, the roof construction goes by pretty quickly.
On our house, getting all the trusses up doesn't finish the roofing, not by a long shot.
Among other things, the barrel vault over the front door will require hand framing.
The area where two sections of the roof meet is called a valley, and these have to be framed by hand. You can't use trusses for these. The soffits at the edges of the roof have to be installed too.
Inside, the vaulted ceilings require hand framing. And the staircase needs to be put in before the rough carpentry job can be considered over. All told, it'll take about 2.5 weeks from when all the trusses were up to when all the odds and ends of rough framing will be finished. And you can see that other parts of the construction will get started even before this is done. It looks like a house now, doesn't it?
Oh, it's amazing what can happen in 3 weeks.
Well, there you have it. The biggest and fastest transformation in the whole building process.
It's a real tribute to the architects, the carpenters, and the lumberyard that framing, which seems so complicated, can go so efficiently.
Still, little problems do crop up. Like when we changed the exterior walls from 2x4s to 2x6s, nobody caught the fact that it would mean moving this window 2 inches to the right.
So the brick that now runs along the side of the garage will overlap part of the window frame. So to avoid this problem, we'll order a slightly narrower window than we originally planned on.
Not a major problem or a big expense, but an inconvenience. You've got to expect a fair number of these hitches to crop up.
There's a tradition that when the framing's done, a branch or small tree is nailed to the top of the roof. Today it's more often done on commercial steel buildings, but we thought we'd do it on our house anyway. It's a signal that one big step of the construction process is over.
And it's a time to step back, admire the work, and celebrate. Because once the framing is done, the day-to-day contracting gets a little more complex, and the gratification factor becomes a little bit smaller.
A lot of processes will start happening at once, and none of them will seem to happen as quickly as framing.
So far, everything's gone pretty much on schedule, up to the framing. That took a little longer than we expected. So we had to push back our next group of subcontractors. And the process has gone in logical order, from the ground up. Footings, foundation, first floor, second floor, roof. But now things start to overlap. Right away, we want our roofing to begin. Our framing contractor will continue his part of the job, which is installing the windows and the doors and the siding. And we're hoping to get started on the brickwork in the next few days. Inside, the installation of the mechanical systems can start. This is the heating, the plumbing, and the electrical wiring. Once the framing is done, these interior and exterior projects can begin at the same time. Although there will be a lot of subs working at once, we'll follow one project at a time, beginning with the heating and the plumbing.
There are several types of heating systems used in new homes: electric, forced air, hot water, and heat pumps. Oil and gas are the most common fuels.
Which type of system you should install with which type of fuel really depends on where you are in the country. Well, for example, hot water systems are used a lot in the Northeast, whereas heat pumps are more common in the moderate climates.
Here in the upper Midwest, most new homes use forced air with a gas furnace, so that's what we're installing, along with central air conditioning. As you get your HVAC bids...
Which stands for heating, ventilation, and air conditioning.
Right. Specify furnace efficiency and the size of the air conditioner. Our bids all include about a 70% efficient furnace and a 34,000 BTU air conditioner. If these aren't uniform, it'll make it difficult to compare bids.
The heating contractor we chose has a very good reputation in the neighborhood, In fact, the owner lives right down the street from where we're building, so we're pretty confident we'll get good service.
The heating contractor is the first person to get in once the framing is complete. His first project is to mark where the heating ducts will go and cut out openings for them in the subfloor and framing. In addition to the heating ducts, this sub is also responsible for some other duct work. This includes the chimney for the furnace and hot water heater, and the exhaust vents for the bathroom fans. The heating sub will do his work in at least 3 different stages. And the first, which is what's happening today, is the beginning of the rough-in work. It's important that this begins as soon as possible because the plumbing work can't begin until the plumbers know where the heat vents will be. But the heating rough-in can only go so far. That's because the furnace hasn't been installed yet. And the furnace can't be installed until the basement floor has been poured. And the basement floor can't be poured until the plumbers have had a chance to lay in any pipes that run under the floor. So, while the heating vents are being installed upstairs, the plumbers are busy at work down here in the basement. These are the drain pipes that will run under the basement floor. They join the pieces together and bury them in shallow trenches. The pipes in the basement floor are the lowest pipes in the drain system.
Upstairs, the plumbers are also beginning the rough-in for the supply lines and the drain waste and vent system. But before we get confused watching what the plumbers are doing, let's examine some fundamentals of plumbing. The plumbing system in any house has 2 parts. The first part to be installed is called the DWV system,
Or the drain waste vent.
In new construction, either PVC or ABS pipes are used.
And that's polyvinyl chloride and acrylonitrile butadiene styrene. These are 2 types of plastic pipes, although some local building codes may insist on cast iron drain pipes.
Each fixture in the house has a trap. This is a small downward loop in the pipe that's always filled with water. The water in the trap keeps sewer gases from flowing back through the fixture into the house. Since a drain system works by gravity, the drain pipes have to slope down, usually a minimum of 1/4 inch down every foot. Drain lines usually run into a vertical pipe called a soil stack. The stack carries the waste down and out to either a municipal sewer system or a septic field.
A vent pipe rises from the stack through the roof. This not only vents off unpleasant odors, but makes sure that reverse pressure doesn't build up in the drain pipes, keeping them from draining properly. The water supply system is pressurized. Hot and cold water run from a source in the basement through parallel copper pipes and into each fixture in the house.
The plumbing contractor serves as a supplier for all the fixtures. This can complicate the bidding a little. To get comparable bids from all the plumbing contractors, ask them to bid the job based on supplying ordinary white fixtures.
Or you can select your fixtures ahead of time. That's what we did. We found a line of products we liked and picked out the sinks, faucets, toilets, and tubs in the styles and colors we wanted. Then all the plumbing contractors bid the job based on the same materials. This way we were able to properly compare the bids. Now the plumbing contractor's work mainly goes on inside the house. But one important part of the plumbing job goes on outside. The connection to the municipal water and sewer systems is made by our excavator. The trench he digs carries a copper water line and a PVC sewer line to the connection point, 17 feet below ground level at the front of our lot. On the house end, the pipes run under the footing into the basement. Just who is responsible for getting the pipes under the footing, the plumber or the excavator, is a gray area. Usually, whoever gets there last gets the job of digging under the footing.
The local gas company goes through a similar process to bring gas into the house. They use a pipe puller to run a flexible tube from the house to the street. As general contractor, it's our job to arrange for the gas service to be installed. Once a meter is in, the heating contractor will run the gas to the furnace.
The plumbing rough-in is moving right along. They've installed the drain vent system first, and now they're ready to move on to the supply system. Since the vent system includes pipes that run through the roof, It's good to get the vents done early so the roofer can start work. You want to avoid cutting holes in the roof after the roofer has put on the shingles.
Once the drain pipes are roughed in, the plumbers will turn their attention to the supply system. This means cutting the pieces of copper pipe and sweating them together with the proper connectors. Right now, their main priority should be finishing up the work inside the walls. Otherwise, they might end up holding up the drywall work. The lines in the basement can wait until later.
One major hurdle to getting all the mechanical systems in is the basement floor. Well, ours is poured now, so the final installation of the furnace and water heater can begin. But getting us to this point, pouring the basement floor, was a project in itself.
We got involved in this project. To try to keep our costs down, we took on the job of installing drain tile under the basement floor. The foundation contractor put sand on the top of the footing to protect it from the mortar that dropped off during the construction. Now we clean the top of the footing off. We need a small trench around the inside edge of the footing for the drain tile to rest in. Any water that seeps into the basement from below will collect here.
The drain tile itself is a large, flexible tube with small holes in it. It lays out into the trench and will carry the water off to a sump pump. The tile gets covered with crushed stone all the way up to an inch or so above the footing.
Remember that the foundation contractor chipped a small hole in the bottom of each block in the bottom course.
This means that any water that collects inside the block wall will drain out through the holes in the bottom block, through the gravel, and into the drain tile, too. To protect the drain tile and the gravel that surrounds it from the concrete, we lay a strip of tar paper over it. Now the concrete floor can be poured and we'll be able to keep water from rising up through it.
Now getting the concrete into the basement is another trick, and we leave this job to the pros. The ready-mix truck backs right up to the edge of the house and pours the concrete down to the basement through a chute. The chute runs through a small hole cut into the subfloor. In the basement, a wheelbarrow brigade starts. They wheel the concrete to the far side of the basement and start dumping it. When a large area has been poured, the men use a screed to level it off. A screed is usually just a long, straight piece of 2x4. It scrapes the concrete to a uniform level.
Now a tool called a jitterbug comes out. This forces down the stones in the concrete, leaving a layer of what's called cream at the top. This thin layer of cream makes for a smooth surface on the finished floor. While the concrete is still pretty soft, they use a bull float on it. A bull float has a long handle. This means they can reach out and smooth large sections of concrete.
Code requires the concrete floor to be at least 3.5 inches thick. The contractor should also either reinforce the slab or create joints to accommodate cracking. And weather has a big impact on how the concrete cures. Special measures are needed if it's extremely hot or cold.
The last bit of floating is done by hand, and then they let it harden up for a few hours.
While the crew was waiting for the basement floor to harden up, they tackled another concrete project, the garage floor. The block around the edge of the garage has a ledge to it. The ledge will actually help support the floor. The floor also is being reinforced with wire mesh.
When the concrete floor in the basement has set long enough to support some weight, the crew lays down some mud boards and crawls out on these to give the floor its final troweling. Troweling seals up the surface of the concrete and makes sure that the top is even, hard, and smooth. There are a lot of different types of trowels. Our crew uses a hand trowel to work the edges and corners. For the large areas, they use a power trowel. The blades on this machine do the work of lots of hand trowels. It's especially useful when you're pouring large, flat areas like a basement floor. The end result of all this work is something we usually take for granted. Something as simple looking as a basement floor.
With the basement floor in, the heating and plumbing subs were able to finish their rough-ins. For the heating, that means installing the ductwork, connecting the register openings together, and installing the furnace.
When the furnace is finally installed, there are a lot of pipes, wires, and ducts running out of it. But with a little common sense, you can figure out what each one does. This electrical conduit brings house current to the unit.
And these smaller brown wires connect the furnace to the thermostat and the central air conditioner. The copper line supplies gas to the furnace. It runs in from the meter outside. The electrician connects all the wires to the furnace. This is done pretty late in the construction process. The heating contractor runs the gas line in. The heated air in the furnace goes out through this duct on top of the furnace called a plenum. There's a canvas connector on top of the plenum that connects it to the hot air ducts. This keeps the vibration of the furnace from rattling the ducts that feed hot air into the rooms of the house.
The principle of heating is to locate the heat source near the area of greatest heat loss. This almost always means near a window. So here in the living room, the heat enters here. Now, since hot air rises, it warms the room from the floor to the ceiling. Then as it cools, it's sucked into this return at the top of the far wall. Now, this may not be obvious that this is a duct, but once the drywall is installed, it closes off this stud cavity, making it into a duct. So the cool air is sucked through the register, travels down the stud cavity, through the hole in the sole plate in the subfloor. Then all the cool air is collected in the basement and fed into the furnace.
Here on the second floor, the principles are the same, but the techniques are a little different. The supply is located near the windows. The return is on top of the wall on the other side of the room. However, this return goes up through a flexible tube above the ceiling and into the other second floor bedroom. Running ducts from the second floor to the basement can be a bit difficult, so our heating sub decided to locate all his returns in one wall. These include the return that's piped over from the other room and the return for this room. Plus, there are 2 more returns for this open area, which includes the staircase and the family room.
In the basement, the returning air is fed through a system of cold air return ducts and back to the furnace. The air passes through an electronic air cleaner and into the furnace, where it's heated up and sent back out into the house. So the heating system reuses the same air over and over again. This is very efficient, but you still have to get some fresh air into the house. Otherwise, the flame in the furnace could burn up all the available oxygen. This is done through this insulated duct that runs from a hole in the side of the house into the cold air return. This is a code requirement in our area, where houses tend to be sealed up very tight in the wintertime, and there may be no other way of getting oxygen into the house. Now, something else we want to note about the heating system. We've installed central air conditioning. The cooling unit is inside the plenum, so in summer, the air going out into the house is cooled up here, instead of being heated by the furnace.
You'll notice, too, that the staircase is in. Try to have the stairs installed as soon as you can. Well, during the rough framing, if possible. It'll make life a lot easier on your plumbers and on the crew that has to pour the basement floor.
Now, to sort out the plumbing system. You'll remember that the water enters here, underneath the footing. The main supply line, or service, runs underneath the floor and up into the water meter. In our city, the plumber gets the meter from the local water company. The water company comes around later and installs a remote meter reader. The water company will typically charge a meter fee, and you should make sure that this is included in the plumber's bid. And the plumber, like most other subcontractors, should include the fee for the permit and arrange for the inspections.
The incoming water runs through a water softener and a hot water heater. The hot water heater has a gas line running into it. Now, the heating contractor ran the gas to the furnace, but it's the responsibility of the plumbing contractor to run the gas from the furnace into the hot water heater. There's the same sort of division of jobs for the chimney. The heating contractor ran the main chimney from the furnace up through the roof, but it's the responsibility of the plumbing contractor to vent the hot water heater into that chimney. Gas and venting for stoves or clothes dryers will be an extra cost, so make sure that you arrange with your heating or your plumbing contractor to take care of these jobs. From the water softener and hot water heater, the main lines travel in 3 directions. The first will feed the master bath on the first floor. Along the way, it has a branch that feeds the first floor powder room. The second set of lines runs to under the kitchen sink and then up to feed it. The third set of hot and cold lines runs to a spot under the mudroom. From there, it runs up into the wall between the kitchen and the mudroom, where it will serve a variety of purposes.
The plumbers created a multi-purpose wet wall here. Not only does the plumbing in this wall service the washer and sink in the mudroom, but it also runs up the wall to service the bathtub, the toilet, and the sink in the bathroom upstairs. Notice how they've made the wall thicker. This is called furring it out. By adding these additional strips of wood, it makes the wall thick enough to accommodate this additional plumbing here.
Our master bathroom is pretty elaborate, but the sinks here demonstrate what a typical plumbing rough-in looks like. The pipes have been stubbed out. In other words, they just end without connecting to anything. And these two copper pipes are the supply for the sink. And this PVC pipe connects to the drain. The drain pipe has a vent rising up from it that goes through the roof. And notice that there are metal plates on the stud walls. These protect the pipes when the drywallers come in and drill screws into the studs to attach the drywall. This sink is a little more complex. There's a vent pipe from the future bathroom in the basement that shares a vent with this sink. And our plumbers decided not to even touch this area until the whirlpool tub was ready to go in. Well, there were too many variables. Where do the faucets go? Where do you connect the water for the whirlpool jets? And how are the dimensions all going to change once the area has been surfaced with tile?
Tile is also a factor in roughing in for the toilets. With the rough-in completed here in the second-story bath, we can see that the plumbers have already installed the toilet flange, but they've left it 1.25 inches above the subfloor. This leaves room for the ceramic tile floor and the bed of mortar that will go under the floor. So it's important to tell the plumbers what type of flooring is going in each room of the toilet and how thick that flooring will be. As you can see, the plumbers have gone ahead and installed this tub surround unit in the second-story bath. This unit was so big that it wouldn't even fit through a door, so we had to temporarily remove a few studs to get it in. Now this should be done during the rough-in stage, while the walls are still open. And this rule of thumb applies to just about any new tub that will be installed.
All of the drain pipes lead back here to the basement. They go under the footing to the city sewer system next to the pipe that brings the fresh water in. And down here is an example of where we spent a little money now to save a lot of money later on. Someday we may want to finish off this lower level and have, among other things, a bathroom down here. So we had the plumbers rough in the pipes for it before the floor was poured. This added about $200 to the bid, but it would have cost a lot more to have it done later. While we've been watching the plumbing and heating systems go in, things have been happening elsewhere on the job site.
Well, for one thing, the electricians started before the heating and plumbing were done. And as you can see, the windows are already in and the roofing is starting to go on.
All of these processes can go on almost at the same time, which means that plumbers, heaters, and electricians may well be tripping over each other on the inside.
While carpenters, bricklayers, and roofers are all working on the outside.
So that we don't get in the way any more than necessary, we're going to go back to the project center, where we've set up a demonstration on basic wiring techniques. An electrical rough-in involves two things, boxes and wires. Now, neither seems very complicated, but a lot of planning goes into their installation. To show you, we're going to wire this demonstration, which will eventually be a kitchen.
Plastic boxes like these are the most common electrical boxes for new construction. They're easy to install. All you need is a hammer and a good plan of attack.
Maybe the toughest part of installing electrical boxes is getting enough room to swing the hammer inside the stud cavities. Using the side of the hammerhead is sometimes the best solution. The boxes have to be mounted so they stick out a little from the stud wall. The front should be flush with the 1/2 inch drywall that will eventually be on the wall. We have to know precisely where the counters and appliances will end up in this kitchen so we can know where to put the boxes in now. Make sure you give your electrical contractor a good set of plans and you update the electrician if you make changes. Boxes are installed for all electrical outlets. This includes receptacles, switches, and lights.
When the boxes are in, we need to get ready to run the cable between them. This means drilling holes through the walls. Electricians tend to drill holes along the stud wall at about knee height. Several cables will end up running through these holes. The holes have to be right in the center of these 2x4 studs. You don't want to have cable running near the sides of the studs where it might get punctured by the screws or nails that will secure the drywall. Where you can't drill the holes far enough away from the edge of the framing lumber, you can attach metal plates to the side of the wood to guard against the screws or nails.
The cable we're using to wire our demonstration is officially called non-metallic sheath cable, but everyone calls it Romex, the brand name of one manufacturer. Romex is used almost universally in new residential construction. It comes in a variety of sizes and configurations, and it's easy to work with. Code requires that the cable is securely fastened. These staples are needed every 4.5 feet when Romex is running along the side of a piece of lumber, and staples are required within 8 inches of any box. A tough part of the job is probably keeping track of which wire is for which circuit.
The last part of the rough-in is to pull the cable into the boxes and to make some connections between them.
This is where labeling pays off. Now we can make all the connections we need before the insulation and drywall go in.
To prepare Romex for making connections, the sheathing has to be stripped off to expose the leads. A simple tool with a tiny tooth in it rips open the sheathing so I can trim it off. Once the sheathing has been stripped, it gets run into the box. This usually entails breaking out a knockout in the box for the cable to enter through. Depending on the box, there may be some sort of cable clamp. When the cables are pulled inside the box, the ends can be stripped, and some of the connections between them can be made.
For instance, all the ground wires can be connected together. Included in this connection is a short wire called a pigtail. This will be used to connect to the fixture that will eventually mount on the front of the box. We can also join some of the neutrals together. Unlike the ground wires, the neutrals for different circuits can't be grouped together. And, depending on the fixture and the circuit, some connections may be possible between the hots.
This is the last chance the electrician has to see inside the walls. Once the insulation and drywall go up, the wiring will be hidden. So a good electrician will make all the connections possible at this point. So less guesswork is involved after the walls are covered, and it's time to make the final connections. And at the end of the rough-in, the electrician will carefully fold the wires as far back into the box as possible. There's a possibility that they'll get damaged by some of the tools that drywallers use to cut holes in the drywall for the outlet boxes.
If this were a real construction situation, the next electrical work wouldn't happen until all the drywall, cabinets, and plumbing fixtures have been installed.
And, of course, we'd need to get a rough-in inspection before the drywall goes in. That way, we could make any corrections now instead of ripping off drywall later to make them.
Our demonstration shows the basics of roughing in 7 circuits. In a complete house, there might be up to 30 circuits, so the scope would be entirely different. In fact, let's take a look. Our design came with a detailed set of electrical plans. So each electrician we talked to was working from the same specifications, which made it easier to evaluate the bids. Not all architects supply a detailed electrical plan, and different electricians will lay out a plan differently. So a low bid may only mean that a contractor is supplying the bare minimum of receptacles, lights, and switches. So it's best to talk this over when you get your bids back. Be sure to check references.
This house will have about 25 different circuits. Well, that's a lot of nailing, drilling, and pulling. As we did in the studio, the electrician will probably do the rough-in in several stages. Working off the plan, he'll nail the boxes up for each fixture. This is also our last chance to modify the layout. A good electrician will probably make a few changes in the plan once he gets into the house and sees how the rooms actually lay out. The next step is to go back and drill out holes for all the Romex. The drill he uses is specially designed for rough-in work and is similar to the ones the plumbers use for drilling holes in the studs for pipes. Next, he strings the cable. Typically, a run will start with a lot of loose cable dropping down through a hole in the sole plate into the basement. Then the wire runs through the studs into the appropriate box. Other runs go from box to box, carrying current or serving as a switch loop. And finally, he runs the wires into the boxes, making some of the connections, usually the grounds. As we look at the plumbing and heating, it's sort of obvious what each pipe or vent does. But even with the wiring exposed, what each electrical cable does isn't always clear.
Our circuits will start in the basement, at the service panel. Most will run across the basement at the front of the house and branch back to where they're needed on the first floor. The north side of the house, with the laundry room, kitchen, and second floor, gets more direct wiring. And in addition to the kitchen and laundry appliances, there are separate circuits for the furnace, the air conditioner, and the whirlpool tub in the master bath.
Okay. During the electrical rough-in stage, you'll probably find a lot of wires dangling in the basement. If the electrician started the rough-in before the basement floor was poured, he'll probably wait to make his final connections until the slab's in. And you'll also find that having a basement makes the electrical rough-in a lot easier.
The electrician can run the Romex through the holes in the joists or between them. So almost every circuit, whether it's on the first or second floor, runs to the appropriate spot in the house through the basement and then runs up.
Part of the electrician's job is to install the meter box. This is where the electricity first comes into the house. The meter box has an opening for the electric meter. The power company supplies and installs the meter itself. There is a fee for this, and it should be part of the electrical contractor's bid. And usually the power company brings the underground power up to the box. But in our city, that job falls to the electrical contractor. The electrician uses a trencher to dig the channel for the cable. The electrical line will have to cross the sewer and water lines. Since the electrical lines get run closer to the surface, we've scheduled the electrical tie-in for after the plumbing tie-in, so the plumbing excavator doesn't have to dig around the electric cables. The cable will be buried 2 feet below ground level. The thickness of your service cable determines how much power you'll have available to you. For our 200 amp service, we need 4/0 gauge cable. When a utility company handles this part of the job, they typically will bring the power to the closest corner of the house. If you want your meter somewhere else, as we do, there's usually a charge based on the number of additional feet of trenching and cable. When the cable gets to the meter, it runs up through a pipe into the box. Power for the house then runs down through a second pipe and into the service panel. Our panel is rated for 200 amps. There are formulas which help an electrician figure out how much service you need. It's always better to have more than you need now, just in case you ever want to add on to the house or install a power-hungry appliance like a hot tub. The panel may be installed before any circuits have been finished and trimmed out in the house. We asked for it early so we could disconnect our temporary electrical service. Often the panel may wait until the trim out.
Oh, schedule-wise, we're doing real well.
Yeah, you're right. Up to this point, we've had probably 8 or 9 subcontractors on the job site, and so far we've been real pleased with their work.
Yeah, we haven't had many problems with any of them, but problems do arise. If you find yourself disagreeing with a subcontractor on materials, scheduling...
Or changes or payments, believe me, the stakes can be large. Well, for instance, we have an electrician that's known to be dependable. But if you happen to get an electrician that's just a couple days late with the rough-in work, it can throw off an entire schedule of sheetrockers and insulators, tapers, finish carpenters,
we get the picture. So you might consider asking your subs to list completion dates on the bid or contract.
Getting things in writing can save a lot of anguish. This is especially true for changes.
If you make changes to the plans or in material specifications after you've agreed on a price with the sub may want to charge you more.
And once you agree on the price, you might want to formalize the deal by doing a written change order.
The sub will probably have forms for this, and you might want to get some standard forms to have around too. Make sure you check out your subs thoroughly before you finalize their contracts. In most areas, subs will have to be licensed, bonded, and insured.
Beware of a subcontractor who wants a lot of money up front. A good subcontractor will have credit with his material suppliers, and he won't need your money to purchase supplies. And watch out for a subcontractor who is changing crews on a daily basis. And beware of a subcontractor who is having a difficult time scheduling material deliveries.
And subcontractors want assurances from the people who hire them. They want to make sure they get paid for their job once it's done. If they aren't, they have the right to file something called a mechanic's lien.
That's a lien against your property, and it's a potent legal weapon. So as you're making payments, make sure that you're getting lien waivers from all of your subcontractors.
Again, this is a standard form. By signing it, the sub acknowledges that he's been paid for either a specified part of the job or the whole job. Now, if all this talk about legal forms and contracts intimidates you, relax. We feel that most subcontractors are basically honest, and if you treat them fairly, they'll treat you fairly. Probably the best advice we can give you is to get a lawyer involved with you in the contracting process, preferably someone with expertise in the construction industry, someone who knows the construction industry standards and practices.
Well, enough of this for the time being. We've got a job to get done.
We do?
Oh, yeah.
While the electrician's working, things might be getting quiet in the inside. The rough carpentry, heating, and plumbing should be finished. And even though work may be going on the roofing and exterior walls, now's a good time to clean up on the inside. Cleaning up needs to be done periodically during the whole construction process. It's a sort of job that none of the subcontractors is likely to volunteer for, so it falls to the general contractor, usually at nights and on weekends.
when you're not in the way of the workers.
Keeping the site clean makes everybody's job easier and safer. And if you establish a mood of neatness, the subs might tend to do neater and more conscientious work too.
Be careful that you don't throw away anything valuable. Scraps of wood shorter than 3 feet can be tossed, and be careful of tools, cords, and hoses.
Hauling the junk away is a big job. You might lease a dumpster for your site, just make sure it gets emptied regularly. However, on construction jobs, it's common just to pile everything up near the street and hire a refuse company to take it away.
Besides cleaning up the job site, another good job for the homeowner is running some additional wiring.
We're running wires for the phone, for the TV, and for speakers. And if we were ever planning on installing a security system, now would be a good time to put those wires in too.
Running these wires is no different than running electrical wires. Some of the thinner wires, like the telephone line and speaker cable, can go through the same holes as the Romex.
Thicker wires, like coaxial cable, require holes of their own. And here we're just using standard electrical boxes.
Smile, Dean.
What's that for?
Well, I figure in about 5 years we may want to add an outlet to this wall, and we won't remember where the Romex is.
So I've been taking pictures of all the walls before the insulation and drywall goes on.
And if we ever need to open up a wall or put on an addition, we'll know what the framing is.
Remember, JoAnne, this entire process is being videotaped.
Well, you know, I kind of suspected that when that guy kept saying
Yeah,
cut all
that's
the
right.
time.
Well, that's as far as we take things in this first tape. We hope we've given you some insight about the first part of the process of being your own general contractor.
The project so far has taken about 8 weeks, and we've only been able to spend a little time on each stage of the construction.
But there's a glossary, some forms, and some reference materials in the project guide if you want to learn more about construction in general.
And if you want more information on framing, plumbing, or electrical, check out the Hometime videotapes on these subjects.
Are we going to keep videotaping here?
Oh, definitely.
Oh, well, then be sure to check out our second Contracting a Home tape just to see how this project turns out. Until then, I'm JoAnne Liebeler.
And I'm Dean Johnson. Thanks for joining us.
Say, I'd like to see that tape now just to see how it all works out.
Hometime is made possible by Chevy full-size pickup, the most dependable, longest-lasting full-size pickup on the road. The national PBS series Hometime is made possible by the Stanley Works. Since 1843, Stanley has been committed to building quality tools and other products to help you do things right.